This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. WorkOS is a modern identity platform built for B2B SaaS. It provides easy-to-use APIs for authentication, user identity, and complex enterprise features like SSO and SCIM provisioning. WorkOS is a drop-in replacement for Auth0 and supports up to 1 million monthly active users for free. It's perfect for B2B SaaS companies frustrated with high costs, opaque pricing, and lack of enterprise capabilities supported by legacy auth vendors. Today, hundreds of high-growth scale-ups use WorkOS, including ones you probably know, like Vercel, Webflow, and Loom. Check out workos.com/SERadio to learn more.
Hello everyone, welcome to this episode of Software Engineering Radio. This is your host Kanchan Shringi, and our guest today is Eyal Solomon. Eyal is CEO and co-founder of Luna.dev. Luna.dev simplifies and centralizes third-party API management at scale. Eyal has over a decade of experience as a cybersecurity engineer. Welcome to this show, Eyal. Is there anything else you'd like to add to your bio before we get started?
Hey, Kanchan. So first of all, thanks for having me. Excited to be here. Yeah, I think I got most of it covered. Coming from cybersecurity, more than a decade in that landscape, and now working on that cool problem of APIs. So I'm in the API landscape.
Eyal, Luna.dev on your website says, and I use that in your introduction, simplifies and centralizes third-party API management, and it's highlighted that this is at scale. So what's exactly new? APIs have been around for a very long time. API management tools have been around for a very long time, and I'm sure there are a lot of API management companies. So what is the new problem that you're trying to solve, and why now?
Yeah, so great question. You got it correct. I mean, APIs has been out there for quite some time. But when we're talking about APIs, there's been a lot of focus on the API provider side, meaning that if I'm a company and have an API that I want to expose out there for customers to use, then comes the API gateways and the API management. Focus on the API provider, giving you with visibility, governance, and controls into your ingress traffic, meaning all of the traffic that comes to your API. But there's two sides of it, right? So there's the provider side, but there's also the consumer side. And for every API provider being provided, there's a consumer that consumes those APIs. And it's a known problem. It's not a new one, but it only takes rise and scale as time goes by. So now we're seeing basically a lot of companies consuming much more APIs and being reliant on much more third-party APIs than they used to in the past.
Yeah, I agree with what you said. A lot of the discussions and toolings have focused on the API provider. Even in terms of the episodes we have done, most of them have been provider focused. I would like to point people though to episode 576 on backend for frontends that did deal with some of the challenges in consuming APIs, but please continue.
We are seeing an immense scale in terms of consumption in recent years, and I think that all proliferation in LLM APIs and also OpenAI actually gave it a real boost. But I think that now there's a real focus of understanding that consumption at scale has costs related to them, not only financial costs, but also costs in terms of the maintenance that has to take place. And now it's like more in the focus of engineering teams out there to make sure that I have full control, visibility, and the right tool set to actually manage that consumption. I think that we're maybe focusing on something that we're pretty out there pioneering that landscape, but the problem is only ever growing as the years scale.
Let's talk a little bit about the current API management companies. What is it that they focus on? And what is it that you mean that they're limited to the ingress traffic? Can you just start with some examples of API management companies?
Yeah, so we can name a few. There's a few cool ones out there, once again, for quite some time, from Kong to Tyke, Apigi, MuleSoft. Those are type of products that are mostly focused on giving you controls so you can rate limit the number of API calls being made to you as a provider.
So as a provider, but so when you consume it, isn't the consumer automatically protected by that?
So that's the thing, he's not. I mean, I can consume as much as I want to, but that API call will be made to the provider and it will be processed by the backend. So it can decide, maybe tell me, listen, there's too many requests, and then you're going to hit me with that 429 back, that response back. But it's still on his side as the provider to limit consumption. He will be the one controls based on those API management, as we said, to decide the way that he want to regulate the traffic coming into him. And basically what Lunar in terms of position is saying, listen, you need to have proper controls when it comes to the client side. You as a consumer, you need to know in advance how many API calls will be made and how you want to regulate that traffic based on your business logic. You shouldn't wait on all of the time for the API provider to give you with a response back. You should take control on your own. Limit and regulate that the rate of API calls being made from your side and from your perspective. Cache those API calls if needed from the client side rather than being API calls being cached from the server side of the provider.
What can API providers themselves do to make the adoption easier, to solve some of the problems that consumers are having? Is there certain things that API providers should adopt, certain best practices that have come out of this increased adoption on the client side?
So it's a valid question. And I think that API providers can do, and a lot of them are doing a lot to help their consumers. API providers are implementing caching, throttling mechanisms, rate limits, regulating the API traffic coming into their backend environment on their own. But we believe that this problem needs to be shared and managed by both the provider and the consumer. It's not enough for the provider to take action because at that point of time, all of your customers are making API calls. It will take you some kind of a processing time and processing unit to decide whether you want to digest and process that API call or not. We believe that the active controls needs to take place from the client side as well, which is not on the API providers to take ownership, but rather on the customers consuming that API. So I think that when we're looking at the broader concept of APIs and API consumption, we need to think about the active controls that needs to take place both from the client side and from the provider side or the API provider side.
So that's an interesting example about caching. So you brought up two issues to start with. One is rate limiting. And to avoid making too many API calls, you said cache it on the client side and not on the server side. How does one decide what to cache, whether it's on the server side or the client side?
So excellent question. And the answer is not that simple. I mean, in order to understand what is cacheable, we need to drill deeper. So you can cache API calls on, let's say, two levels. You can cache based on the header. You can see patterns that kept recurring in the header. But the thing that we understood as more interesting as we've seen companies implemented caching on their side is that what is cacheable will be within the body of an API call a lot of the time. So think about it. Let's say that I'm making an API call to a map service, right? A map provider. Within the body or within the query param will count the content of what is the location that I want to make a geo query upon. So let's say that I want to query city, New York, then that content will either be in the body or sometimes within the query param. Those will be the type of things that it's important to keep track on and have visibility in order to decide what's cacheable. So let's say that I'm having like a lot of API calls being made to that service provider, to that map service provider. I want to understand if I'm making a lot of calls with city New York or maybe a lot of calls with city Hong Kong. And then I want to say those will be the one cacheable. So instead of making all of those API calls every time, I want to store some of them locally as cache. I want to give them a TTL. I want to give them like maybe a payload maximum size. And basically, I don't want to go to the API provider all the time. So actually, by enforcing those type of logic, you can avoid going to the API provider every time for every single API call and make your backend infrastructure much more resilient and efficient and also cost effective when it comes to the number of API calls being made to the actual SaaS provider. That type of logic is a type of logic that in order to enable it, at first, you got to have full visibility to every API call being made and also to the body and the content of that API call. Only by aggregating those data metrics, you will be able to understand what is cacheable, what is not, and how to enforce that caching.
So that was a very specific example, and sounds like now that a lot more organizations are adopting APIs, so a lot of these problems are becoming more prevalent. Do you have any numbers on how much API adoption has increased over the years and what is it now?
So in terms of API traffic in the internet out there, one of the recent surveys that actually is not that updated, I think it's like 3 years ago, something like that, from Cloudflare, talks about more than 80% of internet traffic is API calls. That's a huge volume. I think that basically what it tells us that most of the communication out there is being made by API calls. So the traffic is immense. Keep in mind that the recent blooming and maybe proliferation that we're seeing across LLM APIs will only get that peak and volumes much bigger because the natural progression is obvious. Companies are having much less functionality written on their own in their backend and becoming much more reliant on the third-party APIs they're integrating with. So as day goes by, there's an ever-growing increase in the number of API calls being made to external providers. And that trend will only increase over time. That's the natural progressions of SaaS companies out there. From building something on their own to relying on other platforms. Let's say I want to now I can develop my backend via Vercel. So it's like a thin layer, right? I can develop my backend on top of Supabase. But that actually gives you the understanding that as companies exporting or maybe like outsourcing a lot of their functionality, it leaves you remaining with the integrations that you're integrating with. So this is like one of the most prevalent trends that we're seeing in terms of consuming traffic. It varies actually across industries. So with each industry, maybe let's give an example. At the beginning, you had only, just to name a few, HR type of APIs out there, the ATS APIs. Now there's like dozens of them. It's in abundance. So that scale in terms of how many API providers can offer you that same type of value proposition is scaling over time. So now you have a lot more to choose from. So in correlation, a lot more API calls being made to those service providers.
I did read in one of the links that you pointed out that I'll put in the show notes that 90% of organizations are now adopting APIs, and sounds like 2/3 of them are using some sort of API management software. But clearly, as you're starting to explain here, that the API management software today doesn't solve all the different problems. Another number that I heard just yesterday was that the Unified Payments Interface in India processes almost 2,400 transactions per second. So that's a very impressive number. Certainly correlates with what you said about 80% of internet traffic. So I understand now why we are talking about API management from the consumer side, and we've covered a couple of examples of issues that are unique to the consumer where you cannot rely on the provider to solve them for you. What are some of the other aspects that consumer API management has to deal with that the provider doesn't? Or maybe you can contrast it with some of the problems that the provider deals with that the consumer also has to additionally add business logic for.
Yeah. So let's talk about what are the things that me as an API consumer needs to take care of or maybe needs to be aware of. So first of all, and everything starts with visibility. I need to have visibility into my egress traffic. I need to understand.
Before we get into that, what about just discovery? How do I even know which is the right API to use beyond reading how to use the API? Let's say I have two different providers for the same functionality. How do I choose between them?
Yeah, so that's a lot to do with reputation. Some API providers has been out there and pretty stable, and what we called an API first companies that are one of their main value propositions is the API that they're exposing out there. Those are pretty known APIs, great documentation, not a lot of breaking changes. companies rely on those APIs. We know a lot of them. I mean, just to name a few, Twilio and Stripe, pretty known household names. But not all APIs are equal, and some APIs are poorly documented. Some companies are exposing an API on their own, but not maintaining it that well. And you can get the indication of whether it's a poorly documented API, reading the documentation, having a look whether there's like a user interface to keep track of API calls. But a lot of the time, you will start working with them. And only once you're working with them and it's running in production at a scale where you got to see the actual problems start surfacing. And I think that like a cool distinction that I want the audience to take into consideration is between the APIs that I want to use and the APIs that I'm being forced to use. And I'm not going to give specific examples out there, but just to give you like that clear separation, the API first companies are APIs that is being known. I mean, developers love using them. We love using them. But maybe you need to use maybe like less documented, less adequate APIs, but you have to use those APIs because they're part of your value proposition within your product and you rely on those APIs. Now problems begin to emerge. So how to choose an API? This is like a valid question that reputation has a lot to do with, but maybe even a more interesting question is, how do I get to understand and choose as I'm consuming APIs in production, whether I'm making the right choice? Maybe I need to shift between one API provider to the other based on a specific business logic, maybe based on latency, maybe based on cost on a typical API call, availability, error rate, just to name a few. So now we're seeing companies taking a lot more logic in their day-to-day operations when choosing which API provider, basically like load balancing between alternatives when they want to consume or getting like a specific value proposition.
Typically, you write business logic matched to a specific API, to the API contracts. So now, do you think that people would want to code against multiple APIs, or is there some understanding that providers have to be more uniform in the functionality and the contracts that they provide?
I love that question. I mean, that question, in order to answer it, I don't think that it's on the provider side to be like unified in the way that they're bringing the value proposition. It doesn't make sense in a way because every company and every API provider has its own type of value. That's what differentiates him. It's up to the consumer to decide which APIs you want to consume. And now we're getting to the problem because I don't want to make a decision in real time, hard coded or maybe like manually on which API providers to choose from. The ideal state that we've seen enterprise companies and savvy techie companies using is basically making a unified facade so that I want to have like a value. So I'm making an API call to a specific provider, and I'm going to give an actual example in a second. And I don't care where that API call will be made to which API provider. The only thing that matters is based on my business logic. What will make most sense to my backend and to the way that my product works in terms of which API provider will process that API call. And to give you an actual example, we can actually see that pattern emerges as so recently someone described it as an AI design pattern. So we actually seen that pattern emerge with LLM APIs. So there's like abundance of API that will give you the ability to like Gen AI type of capabilities. You have Bard by Google, and you have ChatGPT by OpenAI, and you have like the open source LLMs, and you have Anthropic, and you have a lot of them. They're not equal in terms of cost, in terms of accuracy, when you're talking about the prompt that I'm going to send and the response that I'm going to get back. And now begins like the hard type of things to take into consideration. Now companies need to think of, okay, where should I make that API call to? Should I always make it to ChatGPT 4 in particular, which is highly expensive, but like known to be accurate? Or maybe I need to differentiate. Maybe some customers are VIP customers. Those customers, I will shift that prompt to ChatGPT 4. But for the less prioritized API calls, I will shift them to one of the open source or maybe to the less expensive API providers. So now you're getting like that proxy logic in the middle of saying for each every API call that I'm going to make, there will be a business logic that can be enforced before making that actual API call to the provider based on cost, based on resilience, based on availability, and like the use cases are numerous. I mean, every company and their own type of logic to take place. But this is now a thing that companies need to think about when implementing integrations and running those integrations in real time and at large scale.
So, a couple of follow up questions on that. What you said assumes that the API is usage based. What about subscription based APIs? What are you observing? Is it mostly usage based?
So the API economy is wide, and I can say how it's divided between API calls, usage-based type of API calls, tiers. Some of the APIs are actually free, a lot of like the known ones. I can say that there's like specific problems associated with each and every business model. So for example, in the usage-based type of model, how do I know in advance how many API calls will be made and what will be the pricing at the end of the month? So visibility and correlation to cost is a big thing that it's missing out there for a lot of the API provider side. For the tier-based APIs, as you mentioned, we're getting it from customers saying, listen, I don't know whether the tier that I'm using is the right tier. Maybe I'm consuming less than what I thought. I need to like degrade to a lower tier. Maybe I need to merge between two teams that are consuming different tiers, but they can be merged to the same API provider with the same key because they will be under the same quota. So every type of business model comes with its own type of problems. I will say that actually we've seen that some of the most problematic APIs that we've helped companies optimize and manage are APIs that are free, basically, or low cost. Those are sometimes the APIs that you have to use and not the ones that you choose to do so voluntarily.
So, if it is usage based, as you did mention, or even if it's subscription based with multiple tiers, as you mentioned, you don't really necessarily have visibility right away into what the cost is going to be. Or do you? Are you saying that teams are starting to project what that cost will be based on how many APIs are getting used?
So in the differentiation that we did a few minutes ago between API first companies and companies that are not API first, we've seen that the API first companies can offer you with a panel that gives you the understanding of how much you're consuming, that cost, even predictions. I mean, look at OpenAI, look at their user panel, and you'll see that correlation. Not all APIs are OpenAI APIs. And as I said, the less advanced, the less API first type of companies will not give you the visibility. So it's up to you to build that visibility. It's up to you to aggregate those metrics and data points and keep track on those API calls to understand what will be the cost. And this is the thing, not only from the cost perspective, but think about it. I mean, you have so much visibility and understanding into your ingress traffic, the APIs you're providing with. What about your egress traffic? I mean, how many companies are keeping track of how many API calls being made from their backend, from distributed backend of multiple services? This is a thing that is both a problem for in terms of cost that, as we claim and trying to convey, will only grow over time, become one of the most problematic issues in productions out there. But it's also a problem that has to do with purely engineering. I mean, if you're not keeping track of the number of API calls being made and the health check of those API integrations, then how will you be aware in advance of what needs to be taking place? I mean, how do you know which type of management and resilience implementations you need to build for each and every API integration? So visibility is a thing that has to do with cost, but also in terms of resilience and efficiency of your backend as well. And also in terms of SLA, right? I mean, you're providing with the SLA to your customers that a lot of the time is being reliant on those third-party integrations. So SLA also has to do with visibility.
I'd like to point listeners to episode 550, Mike Fuller and JR Storment on Cloud FinOps, financial operations. So since this certainly is starting to be an area that people need to focus on, as Eyal, you mentioned, how do they even know how many API calls they're making, what their SLAs are to their customers, but also to track spending. A lot of companies, and you certainly mentioned OpenAI, has usage information. How do people consume that? Let's say you have that information, you have all this data, you collect it at the end of a certain period of time, and then you use it to refine your policies, or is there another methodology people adopt or you recommend?
So I think that the way that companies do it is actually correlating to the stage of of the implementation that they've built. And I'll explain. Talking with many customers about their problem with API consumption, here at Lunar Dev, we understood that there's like layers in terms of, let's call it an evolution of middleware, right? So there's like three layers that we have identified. And at the beginning, we've seen that the first layer is basically like the layer that we're all aware of. I'm a developer, part of the application development team. I'm the one responsible of integrating with a third-party API. If something goes down or problematic with that API, it's up to me to fix it. And that will be most of the time ad hoc fixes. So visibility, I'm just going to implement basic visibility. Maybe I'm going to connect it to an APM, like my Datadog or my New Relic, or maybe, I don't know, even Grafana. But that will give you just like the basic understanding of traffic. Once again, not the full content of a payload within an API call, but just like the basic stuff. But as we've seen companies scale over time, that actually become a more centralized problem. So now we've seen actually companies dedicating teams, mostly the integration team, to build some kind of a managed solution out there. We call it a stateless middleware. At that point of time, we've seen that companies are now adding the ability to basically edit requests and responses. So now visibility becomes to be even better. Now you can collect metrics and traces. Now maybe it's just the very, very beginning of observability. Now you can actually sometimes tag API calls, and you can build more sophisticated middleware than just throttling.
You talk about it being stateless as compared to stateful that remembers. What all does it remember?
Nice. That's what we call the holy grail. This is like the third layer. This is enterprise grade type of API middleware. Basically saying that not all problems can be solved by wrapping up code or by adding code on top of your existing application. Some problems needs to have unified orchestration between them. It means that you need to have a dedicated service. We call it like the egress service that will hold a state between multiple services consuming, let's say, the same API quota. I'm going to give an actual example. We've seen one of our customers consuming the same API provider. I'm not going to name because it doesn't matter which API, but it consuming it both from staging and production. Staging and production are sharing the same API key. Now, they have like a limited quota, right? I mean, this is like the number of API calls you can make in a specific time frame. Might that be a year, a day, a month, or a week? Now we're seeing that they want to prioritize calls between production and staging because production is, of course, obviously much more important than staging. So now you need to shift the traffic or maybe regulate the traffic coming to the same API provider so that 80%, for example, of the traffic will come from staging and only 20% will come from production, and 20% will come from staging. And now you can add more complexity on top of it. Like besides deciding what will be the balance between two services, how do you manage like that remaining of a quota if you didn't reach to that peak, that spillover? All of those logic that needs to take place cannot be solved by just implementing additional code. There needs to be a shared state that understands the current, let's say, quota in that example between different environments, some even like different customers, different tenants, and decide based on your logic how to regulate that traffic. And this is just to give you one example. Take that concept and now make it like even on a higher level. Think about the ability to regulate traffic and decide traffic between different regions, for example. Because our implementation, that egress proxy is a proxy, then you also need to load balance and scale that proxy on its own. So that if one proxy is being, let's say, bounded by the number of API calls that it can process, you need to have another scaling horizontally to another API proxy, another egress proxy. Basically, what I'm trying to say is that for the complex type of problems that has to do with usage at scale, this is when we've seen companies, and once again, a lot of them has been enterprise companies or companies that serving enterprise customers are building or trying to build their own dedicated type of egress middleware that has a shared state to it, because this is the way to go. And this is the natural progression of companies that we've seen from basically no middleware, just wrap things in code, to actually a stateless middleware being implemented a lot of the time by integration team, to that holy grail of a dedicated egress service, a stateful type of service, type of middleware, that a lot of the time is under responsibility of the platform team or the infra team. Sometimes it's like a dedicated task force from the R&D. But this is like the way that we've seen. At Lunar, basically what we're doing is providing you with a production grade ready enterprise type of service. We're saying in that build versus buy dilemma, we're like that fine grained type of tool that will give you all of that, both visibility and controls to your traffic at scale between different services, between different distributed environment. This is what Lunar is set up for, to actually build and solve as an ever-growing type of problem.
Hey innovators, the IEEE Computer Society's door is wide open for your next big idea with the Emerging Tech Grants Program. Dream big and you can land funding between $25 and $50K. Jump on this chance at our website, computer.org/tech-grants. That's computer.org/tech-grants.
Before we get a little bit into more details of solutions, Eyal, I wanted to cover any other areas of issues that clients need to deal with. Maybe let's talk about security next. And what is it that one needs to do on the consumer side over and beyond what the provider is taking care of?
Cool. Let's talk security. Speaking with customers, so security is like an emerging thing. And basically, once again, there's been a lot of focus on API security on the ingress side, helping the API providers. But basically, when it comes to consuming third-party APIs, this is like a no man's land. Basically, like saying that you trust the integration that you're working with. I mean, once you've done the integration, you're not thinking a lot about the data that is being transmitted outside via an API calls. And this is a potential security breach on its own. So I think that the latest OWASP in API security that actually released like just a few months ago is strictly saying unsafe API consumption, like in those words. Basically saying that if the API provider has been breached, then it's a supply chain kind of attack. So that API provider is now being compromised and you can tag it as malicious. So now you're making an API call and that provider will tell you, listen, you want me to give you data from that specific API endpoint? Cool. How about redirecting here? And that redirection, who's checking that redirection, whether it's a malicious endpoint or not? So basically, the answer is that no one at the moment. No one is checking all of those, where the API provider is deciding to redirect you. And that can be a security breach, as I said, on its own. On another perspective, how about PIIs and tokens and all of those data that can be shared and exposed to the API provider? Not a lot of companies are keeping track and auditing which PIIs has been sent and leaked outside. And it's also become to be a thing. So this is another aspect that needs to have proper management and controls on top of it. It doesn't just end with having visibility, which is, once again, a big thing. You need to have that proper visibility and auditing. It also has to do with controls. Once you're understanding that maybe something is malicious or that you do not want to make that API call, maybe you don't want to even get that API response back. You need to have some kind of a mitigation layer in between, as we've seen it like with the egress proxy, that proxy in the middle that will take an API request, an API response, and have some kind of a ruling logic on top of it before processing or making that API call to the provider or back to the back end of the consumer side. So egress traffic and the security of egress traffic is also something that we've seen companies talk with us about and become to be a thing. We can also talk about authentication. Who's managing authentication? Authentication can be managed from that proxy side of things or not, right? So this is another thing that has to do with security. And once again, the thing that I want to maybe convey our listeners is that think about your egress traffic. Think about how much visibility you have. Think about the proper controls that you're enforcing on top of that traffic. That can come with security, cost, and efficiency if we're talking about the engineer side of things.
So certainly those issues all in both the development aspects and monitoring aspects, starting with ensuring you're relying on API first companies and their documentation for discovery, making sure that at runtime you're operationalizing tracking of uptimes and SLAs, number of egress traffics, how the costs are changing. You're definitely orchestrating APIs, but now you're potentially orchestrating them across multiple API providers. You're doing load balancing, you're dealing with throttling on the provider side, you're potentially caching queries, caching API calls on the client side as well for optimal cost. You having to deal with security aspects and certainly authentication at scale. So I get it. It's quite a number of things to handle. And you started to talk about build versus buy. If I do want to build, though, and I don't want to build all of it, what is available in the market today? What are the technology pieces that I can buy to further build my solution?
Cool. So basically, what we've implied along the conversation is that you need to have a proxy in the middle. You can call that proxy an API proxy, right? Something a lot of time you can dub it as a reverse proxy. So that between your backend and the API providers, there will be some kind of a layer in between that will count metrics, give you that visibility that we're talking about, that needed visibility, and also the controls on request and on response. I mean, before API call being made outside and before it comes back. Keep in mind that that control needs to have before the API call will be encrypted, because as we talked about, the actual data that is interesting to take controls upon will be within that body of an API call. So you need to look at the traffic before encryption in order to make sense out of it. And at the moment, the things that you need to do when you're building it on your own is take a proxy, either build it on your own or take some kind of an open source proxy and build that layer on top of it. But it doesn't stop there. You don't need just to build that proxy that will handle API requests. You need to intercept the traffic. And now in today's environments, it's a distributed environment. There's a lot of, as we said, a lot of services, a lot of clusters. How do you intercept that traffic? And now, once you intercepted that traffic, you need to think about the next phase. How do you prevent it from that proxy to be a single point of failure? How do you manage availability? So if one proxy goes down, one will come up. How do you manage scale? So that you want to load balance between different proxies as they scale and as your API consumption scale. How do you keep track of low latency? Because some of the companies that are consuming APIs need to have like a really low latency in terms of meeting their SLAs. So how do you keep track that no added latency will be added? How do you endure peak traffic volumes so that if, I don't know, let's give an example of a e-commerce type of company that's serving a lot of customers out there, and now it's Cyber Monday or Black Friday. How do you manage that peak traffic in terms of volume of API calls? So everything to have, when you're thinking about implementing or building something on your own, you need to think about that auto-scale infrastructure of those proxies. You need to think about fail-safe, fail tolerance, high availability. You need to think about how I'm making sure that there's no impact in terms of latency. How do I endure peak traffic? And another thing to keep in mind is that how do I make sure that the infrastructure that I've built on top of that proxy is configurable? Because it doesn't make sense to just build it for one team. Once you've built it, you need to think about the other teams in your organization that will need to use that proxy. So I'm making sure that they can actually have configurable type of logic within that proxy so that they can actually answer different needs. And as we've seen with companies are now consuming dozens, if not hundreds of APIs in production. So you need to think about the concept of how you can do reuse of those logic and not build everything from the get-go for each and every new type of integration that will take place. So if you're thinking about building something on your own, that egress controller, as we say, you need to think about scale, latency, configurability, and measuring the impact of your operations.
Okay, that's quite a lot of work. And what I found interesting is that Lunar is actually open source. So I'd certainly like to, in the next section, talk a little bit more in how exactly Lunar has enhanced the egress proxy to handle these problems.
Yeah, we're open source because we believe that it's the way to go from a few points. First of all, is as follows. We need to build trust with our community, right? So no better way of saying, listen, this is the code, and you can look at the code. And it's not a black box. I mean, we understand in order to have a proxy that sits in the middle between your backend and the API calls that you're making, those business critical APIs, you need to have trust with our solution. So part of that trust will be open source. Another thing that we understood why it needs to be open source is because you need to know that that proxy is configurable. So you can add on top of it. So if you want to take that proxy and build your specific logic on top of it, you can do so because it's configurable. So this is another thing that is associated with open source. And maybe the third thing about open source, and the reason that we decide to go open source, is that because that problem that we're trying to solve of managing and optimizing egress traffic, your third-party API consumption, it's really a distributed problem. There's no way in hell that we can answer all of the needs for all of those companies out there consuming millions of APIs with their own type of business logic. It will be pretentious of saying that we can do so. But what we can do is build a platform that companies can build on top of that platform so that that aggregated data that the community will build will be something that is shareable. And basically we can say like to the next customer that will come and use Lunar, and this is what we're doing at the moment, is listen, you're consuming API X. We know that API X is problematic, but we've seen other companies implemented caching with those cache keys and values to solve a problem associated with cost or maybe like high latency. So this is like another thing about saying like the community is part of building that product. And this is like another aspect of why that product needs to be open sourced.
Thanks for the introduction on the lunar.dev as an open source and your intention and your goal and vision for it to be used as a platform. Could you start with explaining how somebody would actually configure the egress proxy for their use?
Yeah, for sure. The beginning is by installing the solution. And the solution, as we said, is built up out of two components. You got the egress proxy, or that egress controller, as we call it, and you have the interceptors. So the interceptors are those thin components that sits on the backend side on a service level or on a cluster level. That is sole purpose is actually capturing API traffic before encryption, and only for the selective type of API calls that our customers want to manage, those will be wired via the egress proxy. Within the egress proxy, the customers and the users will be able to define policies before the API call actually being made to the SaaS provider and upon a response getting back from that SaaS provider. So the thing that actually is taking form is the ability to decouple between the maintenance code of that API integration and the actual integration. So if up until now, developers were to build on top of their code and maintain their own type of middleware implementations, such as caching and throttling, now they can do it as a policy. The way that it works within the system is that once you're seeing all of the API traffic, that egress traffic, you can define policies. At the moment, we've published a few policies. We call them building blocks, right? So you have a policy of retry, policy of caching, a policy of load balancing of traffic. Those type of policies are building blocks, and customers can configure pretty much basically everything that they want to do. So I'll give you like a strict example. If you want to define client-side throttling, the thing that you want to define based on the way that you're consuming that type of API provider is, let's say, how many allowed requests can I make in a specific time window? So I want to define as a user, as a developer, I want to define the time window of that throttling. I want to define the number of requests. I want to define the status code by which a trigger will be made. Whether it be a 429, for example, of too many requests. If you want to do client-side throttling, you want to do it once you're going to hit peak traffic, seeing those 429s from the provider. So all of those things are configurable on top of a policy. Another example is talking about caching. You want to define caching. So it will give you the ability to actually define rules for that caching. For example, what will be the cache keys? What will be the TTL of those cache keys? What will be the max size of the caching and for storing each cached call? So this is the type of configurable infrastructure that we're allowing our developers to build on top of the system. Step one is using those building blocks. Step two of the system, which we're working on at the moment, assuming it will be released by the time the podcast will be released, is what we call chains or flows, which means that you can actually chain between different policies. So if you want to do throttling with a queue, a prioritized queue, you want to chain between retries and alerts and all of those complex logic, you will be able to do so on your own, just like as a simple drag and drop type of flow.
So is that sufficient? Is configuration? Are there cases where clients actually have to extend the proxy with code?
That's an excellent question. The answer is yes. And because we understand that the platform needs to be extended by our developers, then we're able to allow so along 2024. Somewhere along the roadmap, we are planning on making the platform fully extendable. So once again, at that point of time, you can define between policies. The next phase will be chaining of those policies. And the third stage will be actually extending it with your own code so that you can actually write additional policies tailored specific to your use cases. So we've seen that in some use cases, you need to define maybe a particular policy or maybe a particular type of plugin that will fit your needs. And this is the way that the system will be flexible and extendable along the way. By the way, part of the reason that we're able to do so is because the egress proxy has been built upon AJ proxy, which has an extendability to it.
I see. So the egress proxy that you mentioned built on top of HA proxy, you earlier talked about the key things that anybody building the proxy, and I guess Lunar has had to consider, and even more because you're offering it as a platform, is the scale, the configurability, the latency, operations, and maybe there's more. Can you just pick a couple and explain some of the challenges you had to face in doing that?
Definitely. I think that when thinking about either implementing or building your own type of egress controller to manage your outgoing API traffic, you need to think about what it takes to be production grade ready. And by production grade ready, I'm referring to the ability to scale that proxy. That proxy can withhold only up until a certain amount of API calls being made concurrently. And with each policy that will take place on API calls, there will be like an added latency. So you need to understand how you can actually make that proxy as a scalable type of infrastructure so that you can actually load balance between different proxies. So you can actually distribute the proxies across, for example, zones or regions, so that you have the ability to have high availability, because if one proxy will go down, another proxy will kick off. So those are the type of production grade considerations that we've seen companies really need to take care of. This is like part of the reason why I decided to go for that challenge and build it on our own, because we've seen a need to actually build something that is like production grade, scalable as it takes. This is like one aspect of consideration. Another one is thinking about latency. We know that some companies using API providers and really sensitive in terms of the latency that it takes to make an API call and get that response back. So you need to think that if you're having a proxy in the middle, how much added latency am I to each and every API call? It needs to make sense. It needs to make it efficient to make that call being transferred via a proxy and not directly. So you need to think about latency and measure it and making sure that it's low as possible. For example, at Lunar, we're benchmarking our latency on a constant basis. I can say that in the P95, we're adding up to 4 milliseconds of latency, which is kind of insignificant, but it's something that needs to be taken care of. This is like a segue to another way of thinking of what you need to do when building your own type of egress controller, which will be measuring the actual impact of your API operations upon that egress traffic. You need to understand what has happened before the API proxy to control and after. So you need to measure that impact. You need to define thresholds. Let's say, for example, you want to define a threshold of what will be the right point in time where another, for example, proxy will take place, or that I'm going to stop some API calls from being made because I don't want to hit those 429s. So threshold and alert of threshold is something that needs to be considered as well. And I'll say that the last thing, which actually reverts to the question that we've talked about before, is the configurability and the extendability of the platform. As we've seen, companies consume dozens, if not hundreds of APIs. And you need to think about a platform that can be extended and configurable to each and every type of API provider, and not just be like that standalone type of solution that it's not configurable and it's like almost like hard-coded. So this is like another configuration we'll build in when you're thinking about building an egress type of an egress controller.
So what are the APIs that Lunar provides your consumers so that they can get visibility into how Lunar is helping, how the egress proxy is helping?
So The way that we're reflecting those type of data and controls to our customers is, first of all, by saying visibility. You need to have full visibility in real time of all of your API traffic, egress API traffic. So the first phase of the product upon installation, once you've installed the proxy and the interceptors, will be the discovery phase. So you're getting that full discovery, which will give you visibility in real time to the APIs you're consuming, all the way to the API endpoint. And then on top of it, we can give you with substantial data to be relied upon. The error rate, even for a specific provider or for a specific endpoint, the number of API calls being made. When was that last time that you communicated with an API and made an API call? The latency that is being measured by an API call for a specific provider. All of those can be under the umbrella of saying this is like the discovery phase. This is full visibility. On top of visibility, because you can define those thresholds, you can understand, okay, now I'm seeing problems within my API integrations. Now I'm seeing that for specific API integrations, I'm hitting with a lot of 429s. So once you will see that within the system, you will have the actual ability to define what we call, as we said, a policy. So visibility, detection of problems or inefficiencies, and then the right plugin. You might define your plugin on your own, or you're getting suggestions of what will be the adequate plugin to deploy to solve that particular need. And that's the way that we actually show you, after you enforcing a policy, what was the impact of that policy being enforced? What happened before Lunar and after Lunar was making its magic with the egress controller?
How can our listeners contact you? And if you wanted to say anything more about the open source nature of Lunar.them.
Yeah, so let's start with the open source part. Lunar is open source. You can actually today either go to our repo, download the proxy, start using it, the proxy, the interceptors, have a go at it. Or you can connect from the UI, which is available from our website, and start getting all of that visibility and enforcement of policies. So this is like one of the, as we talked about during our podcast episode, this is one of the key things that Lunar is all about, being out there for the community. The managed version of Lunar is the thing that we're going to charge upon. And this is something that is also being available to upgrade from the UI. And in terms of contact with me, please feel free. You can either contact me via our website, via LinkedIn, Twitter. I mean, we're available out there, Discord, you name it. We're out there. We want to hear you. We want to help you out dealing with your API traffic problems. Just give me a shout out and talk to me.
So I'll reach out to you for your Discord handle and LinkedIn contact, and we can put that in the show notes.
Perfect.
All right. Thank you so much, Eyal. Is there anything else you'd like to add before we end today?
Thank you so much for the opportunity. It was a pleasure. And yeah, let's optimize API traffic.
Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.